Let's proceed with this first group of materials known as this conductor. So, we have here, ito siya, conductors. So, conductors, during 18th century, si Benjamin Franklin, siya yung naka-notice ng substance that can conduct fluid. At tinawag niya tong conductor, wherein ang conductor is, a conductor has a electric charge known as the electrons that can move freely. Again, conductors is a materials that can be classified by their ability to conduct electricity. This ability is related to the valence electron. So, conductor, one of the best example of the good conductor is the copper. Kasi it has an only one electrons in its valence bond, which can easily escape to the conduction band, leaving behind a positive ion, the core. So again, ang example ng conductor is metals, and copper also is an element that has one valence electron in a valence shell. So meaning, ito yung example din ito ng conductor. So as you can see, ito yung illustration natin ng Bohr model of the copper. So we have these 1 valence electrons at the valence shell at saka 28 na electrons at the inner shell kasi we have this positive 29 at this nucleus kung saan mayroon tayong core na positive 1. So again, the core net charge of this copper is equivalent to positive 1 kasi we have this positive 29 at the nucleus, which means ang positive 29 na ito indicates that we have 29 protons at the nucleus, and we have this negative 28 electrons at the inner shell kasi meron tayong core net charge na positive 1. So that is the copper. So like all metals, copper has many free electrons which are loosely held by the attraction of the positive metal ions. Again, ang example ng mga conductor are those elements that has only one valence electrons at the valence shell. Kasi itong valence electrons na ito can move freely. Wherein, these valence electrons again can move freely kasi they are loosely bound to the atom. So again, valence electrons can, this only one valence electron can move freely because they are loosely bound to the atom. And as these valence electrons can move freely, it will move from this valence band to the conduction band. And that valence electrons that move freely is what we call the free electrons. Kaya naging conductor siya kasi there are the electrons can move freely. Compare dito sa insulator. Itong insulators na ito, these are the materials that does not conduct electricity. This is because itong insulators na ito, yung electrons ng insulator is tightly bound to the atom. Compare sa conductor, yung electrons ng conductor natin can be moved freely kasi they are loosely or they are unbound to the atom. Again, for the insulator, they are tied up to the atom. Kaya hindi sila makamove. Or there is a few amount of electrons that can move from this valence band to the conduction band. So that is for the insulator. So examples of the insulators are the non-metals. So non-metals such as glass, air, paper, rubber, and are excellent and those excellent insulators that are widely used for electronics. So as I've said, yung insulator does not conduct electricity for a reasons that they are tightly bound to the atom. Yung electron ng insulator are tightly bound to the atom. But, or however, itong materials na ito, itong insulator na ito can conduct electricity if and only if they have a large amount or they have the large amount of voltage. They have the high enough voltage. And also, there were a breakdown that will going to occur. So, again, ang difference between the insulator at saka ng conductor, ang conductor, yung electrons ng conductor are loosely bound to the atom. That's why they can move freely. compared to these insulators na itong insulators na ito, yung electrons niya are tightly bound to the atom. That's why they cannot they cannot simply move freely. There is a available free electrons that will going to move from this valence bond to the conduction band. So that is the insulator at saka ng conductor. So let's have this third type or third group of the materials known as the semiconductor. Itong semiconductor na ito, this is neither a good conductor nor a good insulator. So one of the best example of the semiconductor is the silicon. Itong semiconductor na to are between conductors and insulators in their ability to conduct electricity. Again, as I've said, the best example or usually or commonly used electrons in the semiconductor is what we have, silicon. So, as you can see, ito yung illustration Bohr's model ng silicon. So, we have these 1, 2, 3, 4 valence electrons at the valence shell. And we have also these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 na valence electron at the inner shell. So, as you can see, we have this positive 14 at the nucleus, which indicate that we have this 14 proton, 14 neutron, and we have these negative 10 valence electrons at the inner shells. That's why we have this core positive 4. So, unlike metals, silicon forms strong covalent bond shared electrons with its neighbor. So, ang silicon, so ito yung covalent bond or sharing of electrons of this silicon. As you can see, they have these 1, 2, 3, 4, 5, 6, 7, 8 shared electrons at their neighbors, which means they have this equal share of electrons. So intrinsic silicon is a poor conductor because most of the electrons are bound in the crystals and take part in forming the bands between atoms. So the band between the atom is this one. So again, intrinsic silicon is a poor conductor for reasons that they have the electrons are bound in the crystal. So semiconductor the best example of the semiconductor is the silicon. Ang silicon can be a diode also at saka ng transistor. So the three groups of the materials can be differentiated by the use of the band gap. So, ito yung illustration natin ng band gap ng insulator, semiconductor, at ng conductor. So, if di-state dito na yung ng illustration ng band gap kung saan there is a large amount of band gap or there is a large band gap, it indicates na kailangan nito ng large amount of energy para yung valence electrons from valence band is makamove from valence band to the covalent band. So, as you can see here in the insulator, mayroon tayong large amount of energy or large amount of band gap, which means large amount of energy is needed para yung electrons natin, valence electrons natin from valence band is going to move from this conduction band. Kasi, mayroon tayo ditong large amount of energy for a reasons that yung insulators natin are tightly bound to the atom. Kaya, there is a few electrons that can move from this valence band to the conduction, meaning as there is a few electrons that can move from this valence band to the conduction bands, meaning there is an higher amount of energy that is needed compared to this conductor kung saan there is an overlap occur. Kasi nga itong conductor, yung electrons ng conductor are loosely bound to the atom. So they can move freely and the electrons can readily move between these conduction bands at saka valence band. So kaya there is an overlap occur here. And this means that ang conductor is highly conductive siya. So, itong semiconductor naman, as you can see here, there is a small band gap occur in this semiconductor wherein yung electrons natin from this valence band can have a certain amount of energy to move from this conduction band. So, yan yung pinagkaiba-ibahan ng three groups of materials in terms of the band gap. At the insulator, yung band gap niya, it has a large amount of energy. While sa semiconductor, there is a small band gap, which means there is a certain amount of energy. While in a conduction, nag-overlap siya kasi yung electrons sa conductor is moving freely, so they were going to readily bound to each, bound from these valence electrons to this conduction band. So that is the differentiate between the different of sa three groups of materials.